All right, we're beginning a little bit of data science here. I'm going to lean on what I've hoped you had some course in statistics somewhere, and we're going to apply t-tests. I don't want to be patronizing, but it may have been a while. But we'll look at it from an applied sensibility and hopefully highlight why we would bother, how the data helps make it, and how it can help us discern signal from noise and that kind of thing. So the idea behind data science or data analysis really is, maybe we see differences but make conclusions, but a statistically significant difference says it's surprising given all the noise, since things can vary. And when I say noise, we're talking about the distributional variation, like variance or standard deviation, can cover what's really happening. If you roll a die, you might get a 2. That doesn't mean the average of a die roll is going to be 2. You roll, if it's a fair die long enough, you'll find the average is 3.5, and it gets closer to that and everything. But maybe if it's a loaded die, it becomes something different. So, there's this statistical thinking that goes on. But especially, making in employee judgments, supplier judgments, and that kind of thing, you'd like to put some statistical teeth in the conclusion. And this is just a demo of how you can do some of that. And it's using Excel, maybe not the best statistical analysis tool. What it can do is a little bit limited, so we are doing tests that lend themselves to what Excel can do, but it's a leveraging off point for that idea that we need this in general, and we are wanting to make conclusions that are valid in the data, not just a quick opinion from looking at the data. So I'm in my OLAP, customer OLAP, and I've done these pivot analyses. And the idea is that pivot analysis can kind of sometimes bring you to a conclusion. One thing you're going to need to do in order to do the statistics is add in the analysis tool pack. So I've gone back here on File, come down to Options, go to Add-ins, highlight the Analysis Tool Pack, press Go, and for us, we need at least this Analysis Tool Pack in. We don't need the others, though, if we wanted Solver and do some multi-currency things. And what that gave us, by the way, I should have done it, that means on the Data tab, there's now a Data Analysis thing. If that's not showing when you get to the Data tab, then do what I just did, and that was File, Options, Add-ins, highlight Analysis Tool Pack, which probably won't be highlighted. Type Go and make sure the Analysis Tool Pack is checked, and then you're ready to go. All right, well, I'm going to pretend that I'm analyzing this data and came up, and I gave you this, and you get to do a similar kind of thing, but I'm looking at all this. Remember, this is customers and suppliers, and the average, the number of shipments and the average gross sales for those shipments, so blah, 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 blah. And now I'm looking at the bottom, and wow, this one kind of sticks out a little bit. It's bigger than the rest. So whatever this third supplier is, we can go up and look. It's got the bigger average on average, but these things vary. Sometimes this one's bigger than that. So the question is that a statistically significant difference? So the hypothesis I want to test is that this third supplier, which happens to be United Package, is its average gross value of a shipment bigger than the others, right? So this one versus the others. So I got to do a little data wrangling, and I'm going to come over here and do it. And so I'm maybe putting reminding myself up here is average gross shipment for United Package more than other shippers. And I mean that in a statistically significant sense. And so what I'm going to do is put a column for United Parcel and a column for others here. I've got to wrangle the data a little. What I need to do is get all United Parcels sales grosses here, and then all the sales grosses for others over here. And I'm going to kind of just do that by hand. I'm coming up here, picking on shipper name and saying, oh, instead of all the shippers, I'm sorry, it's United Package. I think I've been saying United Parcel, but United Package. Great. So when I do that, I have just United Package. And so I can highlight this up at the column, and right click on it and copy, come over to where I'm doing the analysis kind of here, and I'm going to paste values here. That 1, 2, 3. So what that is, that's the order gross for United Package, right? And all of them, it goes down for a ways. Well, now I want to get the data for the other. So this is wrangling the data. So I'm going to do this and select all and everybody besides United Package. Okay, so this wasn't too bad. It's just the way the t-test analysis tool works in Excel is you need ranges with the one set of values you want to see, is that on average different from, and this is the other range of cells. They don't have to be columns side by side, but that's what makes, it just was easiest and kind of makes sense to me. Great. And so now I'm ready. If you're not already on the data tab, I'm going to do data analysis. We're going to do a t-test. So if you go down, and I'm going to start with the t-test assuming equal variances. It'll calculate the variance, and if you find that there's a significant difference in the variance, like 4 times more or 1/4 of, then we need to do the unequal variances t-test. But I usually just, if I'm working, and this is kind of exploratory, trying to do something, kind of a back of envelope, but with a tool, and we can clean it up for presentation. So I'm going to assume equal variances. What it wants is, well, where do I find variable 1? It's best to, you can do some of this by clicking in and pointing, but it's best to kind of hit that little doohickey, kind of come to the start. If I do shift and down, it will highlight to the end of all the data in that column. Then I hit that doohickey again, and it puts that range in. Okay, hit this little pointer doohickey, come up here, start on this, shift and down, it'll go down to the end of that range. There happen to be more of the others than there do for the 1, and that's okay. When we're looking, is there a difference in means? What we're, the hypothesis or null hypothesis is no, there isn't. Okay, and then we maybe reject that null hypothesis or not. If we fail to reject, then we have or should conclude, well, it was all in the noise. Okay, even though the average worked out higher, it's like if I roll the die 3 times and I roll it 3 other times, one set might be a higher total than the other, but that's not a statistically significant difference. And at the alpha level, we usually leave that 0.05. The idea is if something is, looks like it's rarer than 5%, due to random effects, then I conclude there's a difference. If it's not, then I don't. And sometimes you can work with the alpha, but 0.05, if you don't have a good reason to put something else for that, is kind of the standard. And instead of a new worksheet ply, I'm going to choose an output range for the analysis. What it does is prepare a little table by way of analysis. I'm going to just put it there, kind of just to the right of this, just for a convenient place to go. All right, so if I do OK, then it completed the analysis for me. Okay, takes a little bit of unpacking, and let me kind of go look at it. I'm just trying to get it all to kind of show on the screen. All right, so we had variable 1, variable 2, and so I'm just okay. And looking at the variances here, and they're comparable. One isn't 4 times the other. You can just kind of look and blah like that. So they're close enough to being equal. If this was 4 or bigger or less than 0.25, we would worry. And that's why I held up a little bit, because variable 1 was the kind of the average of all these for the one we thought was bigger. I had it backwards. So we really are looking, this was United Shipping, this variable 2 is everybody else, and so that should be less. So the averages, the variances are close enough to equal. We believe this analysis. There's some other things we can look at, but what we really want for a is one bigger than the other is the one-tail test. And what we want, if we're just saying, are they different? Is it either bigger or smaller? We look at the two-tail test. But in this case, both of those are bigger than 0.05. What we can say is this is the chance that the difference we're seeing is due to chance, is how you sometimes phrase it, okay? And if that's bigger than 0.05, we can't conclude there's a difference, all right? So, a conclusion that the p-value uh, 0.13, and that's greater than 0.05. So do not conclude a difference in the means or averages. Yeah, means kind of. All right. So, even though it looked like perhaps United Package average, had bigger shipments in terms of gross dollars, it's really not stuck its head out of the noise, and we should pretty much, we conclude that, it's not statistically significant bigger. It's pretty much the same as the others. All right. So, but now we have a statistical reason, and that kind of goes against, the calculated values say, they're, looked like, a difference. It is bigger, but it's not enough, okay, bigger, to make a difference. All right. Another one I'm going to demonstrate, and I did two, coming up. And this one, it's also interesting. I was looking at this, and I'm, this stuck out a little bit. We're discount percentages. Now, is Robert King, is he just, driving up sales? Well, doesn't have the most sales, trying to catch up on sales by giving people discounts. There's maybe a question, is he authorized? I think maybe he's the boss or something. I'm not sure on how we could look how Northwind's organized, so maybe he's discounter of last resort. But so the question that I want to answer is the discount. Is the average discount Robert King gives on orders larger than the average discount amount? You have to worry, because average discounts, they could be related. Then we might look at average percentages, but I'm going to do the amounts. Okay, so it's kind of the same principal idea. Let's see, and are King's average discount amounts bigger than average of others? Now, and my other employees, right? And so I'm going to do an R King here. In this case, it's others. I could just pick out one or the other. Going to go back to here. Got to remember, sometimes if you've put in a filter somewhere along the line, you want to hit this clear button. That'll clear all filters, because it was filtered for, one of the shipper names and something like that. But what I'm going to do is just say, well, let me get Robert King's data. Okay. And we're looking at discounts here. Copy. And again, we're now setting up, doing this. It's called wrangling in general. The converting, your book chapter talks about all, that's the thing with data science and data analysis. You often spend a lot of your time working things around to get them in the right format, clean it up for analysis. But let's come back here and say, okay, we're checking, versus all others. I could check Robert King versus one person or something like that, but everybody but Robert King. All right, gonna copy that data, get it just over here, paste it there. And now I'm going to do a t-test. And again, in this case, I'm going to start with, assuming that it's the same sample means. So the data range for 1 is this guy, right? All Robert King's data. The data range for the second sample is all those guys. I'm hypothesizing a mean difference of 0. We're looking for that bigger than or less than. And I must have got I must have hit something in there. Let me just make sure I got it. Right. And I don't know what I did. I hit a parenthesis there at the end because went back to like I was writing a formula, and a lot of times you put a parenthesis after the range. Okay. Oh yeah, and now on the well, let me just cancel that. Not paired though. I'm doing that's why I was doing the wrong test there too. Assuming equal variances. Okay, so it's kind of remembering my other one now. That's the thing. So make sure you get dip and down, blop, and all right. God, I did that again, didn't I? Just press enter when you're done, or hit that little doohickey again. And I did that too. Mean difference, but the output range we want. It's back up here at the top. I guess that N3. Dang, see what I did? I was looking at this, but yeah. So I was just getting this set up. Is good. Just double checking I have the right ranges. Good. Mean difference. Make sure, click on the doohickey. And so N3, notice that when I did it again, it put in double. So there we are. So that was kind of a little fat-fingered, but the two ranges, hypotheses mean that 0 is typically the case. You might say, oh, it has to be more than 1,000 bigger than before we count, and you could do that. Alpha level, the results are going to go there. So I did okay, and I'm looking at it, and now, though, I am a little, or should be concerned, the variance of the first variable is more than 7 times the variance of the second variable. And so we ought to use that test that says the variances are different. Okay. And so it's fine. One thing, you can either erase all this, or if you use the same spot, it will tell you it's putting it over the top. If you want to get rid of all those lines, we can do, it's the lines thing. I always lose it. Here we are. And no borders, just to kind of clear that out. Could good. So let's do that test. So back to data analysis, but assume unequal variances, and it goes just the same. I practiced enough times on this one. I shouldn't fat finger it too bad. All right, those are the two data ranges. I'm not sure what labels does there for us, but output range. We want an output range. Click the doohickey, and we'll put it in there. Alrighty, and unequal variances. Okay, so now it looks the same. There's some calculations that go different. And remember, we are looking at the one-tailed version, just as bigger or smaller. Actually, yeah, the two-tail isn't statistically significant, but the one-tail version is. That is, this is 0.028, and so conclusion: the one-tail p-value is 0.029 if we want to round it off, less than 0.05. So a statistically significant difference in average discounts. So not only does it stand out when we look at it here in the chart, it stands out in terms of a statistically significant difference. Again, it says there's about a 3% chance, 2.9% chance that the difference we saw were just due to random variation. Most overwhelmingly, 97% chance that it was a signal in the data, and if that happens, then we run with it. Yeah, and so that's looking at one kind of test, t-tests for difference of averages, but trying to get you used to, maybe dusting off some of that statistical processing and thinking, and not, and realizing that data has variability, and so just an average isn't enough. Sometimes you need to, look at against the variation and make a more scientific conclusion. All right, so that's a little bit on hypothesis testing. Again, ta-ta for now. We'll see you another time. Bye-bye.